All right. So when we perform math with measurements, right, the resulting answer is a little bit different than if we just do math in math class, where the numbers are beautiful numbers that represent something, but not necessarily measurements in our own mind. When I use numbers that are actually represent measurements, I need to make sure I recognize that the uncertainty needs to be expressed in the answer. All right. So if I take 3.14 times 2.751 divided by 0.64 in my calculator, this is an example of what I'll get. But this can't be the right answer in chemistry class because this needs to, again, contain the uncertainty that's going to be expressed in the answer. All right. So 3.14, how many significant digits are in the answer, or the value 3.14, Fred?
Oh, that's three significant digits.
Very good, 3. And 2.751?
That's four.
And then here?
That's two.
That's right. So if I take a number that has 3, times it by a number that has 4, and divide it by a number that has 2 significant digits, how many significant figures should my answer have?
Do you average them?
No, you don't average them. You take the smallest number. When you're doing multiplication and division, you take the smallest number. So my answer is only going to be able to have 2 significant figures. Therefore, I take this value and I round it to 2 significant figures. So my answer for this question is going to be, let's see, if I round with this 4 here, I don't worry about the 9, I just take this 4. Is that going to round the 13 up or down?
Um, it's just gonna, well, up or down? What do you mean?
Well, is it going to stay 13? That's called rounding it down. Or is it going to round up to 14?
It's gonna stay 13.
Very good. So I round it down to keep it at 13. All right. So the answer is going to be 13 for my answer, and it's going to contain 2 significant figures. And the reason we had to do that is because here we had a device that could measure 3 significant figures. This one could measure 4, but only this would go and measure 2. So we're limited by our least precise device, right? The device that had the fewest number of significant figures. All right, so looking at this, I have a multiplication problem. How many significant figures should result from this answer?
Um, you mean what's the answer?
No, not what the answer is. Let's get my calculator here. If I take 12.33 and times by 0.00002, right? 12.33 divide or times 0.12342, right? I have an answer there, 2.466 times 10 to the minus 4. But the question is, how many significant digits should be expressed, right? So I've not asked for what the answer is, but how many significant digits should be expressed?
Um, is the answer none of these?
That's right, it is none of these. The answer is only one significant number should be expressed, right? And that's because one of my values only had one significant digit. Therefore, my answer in multiplication and division, recognize that I keep emphasizing multiplication and division because the process for identifying the number of significant figures in addition and subtraction is different. Okay? All right. So here is addition and subtraction. For addition and subtraction, if I were to add these values together, I would get something like this. All right. Well, actually, I want to get something like that. Let's do it in the calculator here. So we got 3.247 plus 41.36 plus 125.2, and my answer is 169.807. All right. But how many significant digits should I keep, or how do I identify how many significant digits there are? For multiplication and division, you just find the one that has the fewest number of significant digits, and that's an indication of how many significant digits you should take. But it's different in addition and subtraction. In addition and subtraction, you have to line up all the values like this, and you identify which measurement has the fewest number of significant digits to the right, or usually beyond the decimal point. And wherever the cutoff is, your answer has to cut off at that point as well. All right, so that's why I need to round at the 8. I look to the right at 0, so it's going to stay at 8. So it's 169.8. All right, so here's another one for you. 10.33 minus 0.0344. All right, while you're thinking about it, I'll do the math in the calculator here. There's our number that we need to round to a certain number of significant digits, and the question is how many significant digits should we have? All right, what do you think, Fred?
I'm not quite sure. Could you line it up for us?
Sure. And again, that's what you have to do. You have to take 10.33. You have to subtract 0.0344. All right, use our arrows here like this. We can write down the answer, 10.2956. But because this one here goes further to the left, I can draw a dotted line here. I know this is the number that has to be round to. So 10.2 and this 9, because this is a 5, we go up. So 10.30, whoops, 10.30, that is going to be our answer. And how many significant digits are there?
Is that 4?
That's right, 4 significant digits. All right, good job. All right, here's another one. Now, in this one, we have a mixed operation. We have multiplication, subtraction, and then division. And that's the way you would solve this, right? You always solve what's inside parentheses. You solve what's above the numerator and below separate, and then you take the resulting quotient by taking the numerator divided by the denominator, right? So, why don't I give you guys a chance to do it? All right. When you do this problem, you have to collect significant digits anytime you shift from addition and subtraction to multiplication and division, or back to addition and subtraction again. So what we need to do in this question here is first we need to do what's inside the parentheses, 10.0 times 10.88. You know what that equals?
I put it into my calculator. It's 108.8.
Very good. This equals 108.8. But how many significant digits should that answer have? Assuming that these are measurements, how many significant digits should it have?
I guess it should just have 3.
That's right. It should just have 3 because this measurement has 3, that measurement has 4. Therefore, my answer in multiplication and division has to have the lowest, so it's going to be 109. 109 is going to be my answer there. Now, the next step is to subtract 12.2. Now I have to do this math and identify the number of significant digits. And again, for subtraction, what I do is addition or subtraction. 109 minus 12.2. All right. Whoops. Try again. Line them up well. 109 minus 12.2. All right. I could put that in my calculator here if I want to. Minimize the number of brain cells I have to use. 96.8. I write that down here. 96.8. And the arrows here, right, indicate to me that I have to cut off my significant digits right there. So 96 is going to be rounded because of that 8 up to 97. All right. So now by doing the math here, I get 108. By doing the math here, I end up with 97. Now I'm going back to division again. So I go divide by 2.2. All right. I have 2 significant digits here, 2 significant digits there. So 97 divided by 2.2, that's going to be 44. And the answer is one thing, but what I'm after here is how many significant digits. This is division, so I started with 2 on both of them, so my answer is going to have 2. So the answer there is going to be 2 significant digits. Did you get that?
Yeah, I got it. That took a long time, though.
Yes, but that's the right way to do it. Okay. So, that's a good place to stop.